So good morning children. So welcome back to the annual session of a physics class. We are discussing about the motion lesson. So in the last video I had explained about the difference between the distance and the displacement. So how to define the distance, how to define the displacement, and what is the difference between distance and displacement, which is called as distance and which is called as a displacement. So when the distance is having a direction or displacement is having a direction, so those things and all I had explained in the last video. So distance doesn't have any direction, distance is having only a magnitude, that is only a numerical value. Whereas the displacement is having a numerical value, magnitude, numerical value is called as a magnitude, and then it is having a particular direction also, very important. So displacement, it is having a particular direction. So it is having, displacement is having both direction as well as the magnitude. So therefore it is a vector quantity. Distance, it is having only magnitude, it doesn't have any particular direction. Therefore it is a scalar quantity. Distance is a scalar quantity, displacement is a vector quantity. So after that I have solved some of the questions, I have sent the answers for that questions. So I had explained that the answers of the questions. Then in the last class I have told you that in the next video we will discuss about the uniform and then non-uniform motion. So let us discuss what do you mean by uniform motion and let us discuss what do you mean by non-uniform motion. Let us write the uniform motion first. So the word itself suggests that what do you mean by the uniform motion. Motion is by moving the object. Okay, if the object takes equal intervals in equal amount of time. For example, the vehicle is, suppose assume that the vehicle is moving in such a way that for the first second it is moving 5 meters, for the next second again it is moving 5 meters, for the third second again 5 meters, fourth second 5 meters, fifth second 5 meters. It is keep on moving like that. So that is called as a uniform motion. Okay, so let us take the formal definition for that. An object covers equal distances in equal interval of time. Equal interval of an object covers equal distances in equal interval of time is known as uniform motion. You can write this in your classwork. Okay, definition of uniform motion and non-uniform motion. Write that in your classwork after the question and answers. Whatever question and answers I have given in the last class, after writing those question and answers, write this uniform and non-uniform motion. Then write the uniform motion. What do you mean by uniform motion? So understood what do you mean by uniform motion? If the object is moving in a straight line, if it covers equal distances, equal interval of time. So that is for first second it is 5 meters, for the next second again 5 meters, third second 5 meters, fourth second 5 meters, fifth second 5 meters. Keep on changing like that. If it is keep on changing at equal distances, at equal interval of time, then it's called as a uniform motion. Okay. So now let us come to the non-uniform motion. Okay. So the non-uniform motion is exactly the reverse process. An object covers unequal distances in equal interval of time. Okay, equal interval of time is known as non-uniform motion. The uniform motion covers equal distances. Okay, in the non-uniform motion it covers unequal distances. Okay, say suppose the vehicle will be moving in a crowded area. Okay, for the first second it may move 5 meter, but in the next second, it can't able to go in the uniform motion, same 5 meter. It may be reduced or it may be increased, right? Suppose it has to cross more signals, okay? So if there is a slow motion, in the sense what will happen? Sometimes it will go faster, and sometimes it has to move slower. So that means at first second you may cover 5 meters, the next second you may cover 10 meters, 15 meters. So it is unequal distances, but the time will be equal, interval of time. First second, next second, first second, second second, third, fourth, fifth. So time will be equal intervals, whereas it covers unequal distances. The first second will be covering 10 meters, say suppose. In the next second will be covering 20. In the next second will be covering only 5. In the next second will be covering 50 meters. So like that it is unequal distances. Okay, it is not equal distances. So that motion is called as a uniform motion. Non-uniform motion. So uniform motion is equal distances. Non-uniform motion is unequal distances. Okay. So this is about uniform and non-uniform motion. We have a table. So I'll write that table to understand the uniform and non-uniform motion. So I have a table. They have given time. First will be time. Okay. Next one will be distance traveled by object A. Distance traveled by object A. Let me take this is object A and let me take this is the distance traveled by object B. Okay. So the time will be 9:30 a.m. 9:30 a.m. at 9:45 10 a.m. 10:50 10:30 10:45. Okay. So 11. The distance traveled by object A is at 9:30 is 10 meter. Let me denote as meter. At 9:45 is 20 meter. At 10 o'clock is 30 meter. 10:45 40 meter. 50 meter. 60 meter. And then 70 meter. Okay. So distance traveled by object B, that is 12 meter. The first, that is at 9:30. Then 90 meters, 23, 35, 35, 37, 41, 41 meter, then 43. So this is a table to distinguish which is uniform motion and which is non-uniform motion. Observe the time first, whether it is having the equal interval of time or not. It is starting from 9:30 to 9:45. What is the difference? Difference is 15 minutes. Correct? 9:45 to 10:30, 15 minutes. 10 to 10:15, 15 minutes. 10:15 to 10:30, 15 minutes. 15 minutes. 15 minutes. Observe that it is equal interval of time. Difference is 15 minutes, difference is 15 minutes, difference 15 minutes, difference 15 minutes. In all the cases, the difference will be 15 minutes. So it is equal interval of time. Time is equal interval. Now, I need to find out that which is uniform and which is non-uniform motion. Now, observe the distance traveled by object A. At 9:30 is 10 meter, 9:45 20 meter, 30 meter, 40 meter, 50 meter, 60 meter, 70 meter. Keep on changing like this. So how to find out whether it is an equal distance or not? Take a difference again. Difference between these two. 20 minus 10 is 10. 30 minus 10 is 10. 40 minus 30 is 10. 50 minus 10 is 10. 60 minus 50 is 10. 70 minus 50 is 10. That means In this interval also it is 10. In this interval also it is 10. In this interval 10, 10, 10, 10. In all the intervals, it is moving at equal distances. So in the equal intervals, it will traveling at equal distances. Okay. Similarly, observe here. Between these two, the distance is 7. Between these two, the distance is 4. Between these two, the distance is 8. Correct? I'm sorry, not 8. 5 plus 7, 12. Distance is 2. Distance is 4. Difference is 2. Now, in this interval, it is traveled 7 meter, but here it is 4, but here is 12, 2, 4, 2. It is not equal. Observe that here it is equal distances, whereas here it is not equal distances. Okay, so which is uniform, which is non-uniform? Obviously, the object A will be moving in uniform motion. Object B will be moving in a non-uniform motion. So this is uniform motion and this is non-uniform motion. Okay. So next we will move for measuring rate of motion. Measuring the rate of motion. The next concept will be measuring the rate of motion. So, if the object is moving in the sense, of course we can say that it is moving. So, whether it is moving fast or it may move slow, okay. But how to measure the rate of motion? In what rate it is moving? So, how to observe that, how to find out that. So, let us see how to measure the rate of motion. So, you may observe that by playing the cricket and all, you can observe that the bowler is bowling a ball at 150 km per hour. Okay, so and you can say that vehicles are going at 100 km per hour, 50 km per hour. What is that? What is that mean 50 km per hour? What is that? You may observe that vehicle is going at 50 km per hour, vehicle is going with 10 km per hour, otherwise cyclones are hitting at 300 km per hour, 250 km per hour. So what is that? So it is actually it is a rate of motion. It is a motion rate. At what speed it is going, at what rate it is moving. So that is nothing but the rate of motion. The rate of motion will be measured in terms of speed. This is again a new physical quantity. So let us learn about this physical quantity, whether it is a scalar quantity or vector quantity, what will be the whether it is having a direction, whether it is having a numerical value, magnitude. Okay. So what is the unit of this? How to measure this? How to define this? So let us learn one by one. So for this, you may observe that different objects will be in different speed, right? Different objects will move in different speed. One object will move in very speed, and one object will be moving faster, and another object will be moving slower. So, like that, different objects will have a different speed, right? So, how to measure that speed? So, that will be measured in terms of, okay, one of the ways, here they are saying that one of the way of measuring the rate of motion of an object is to find out the distance traveled by an object in unit time. So, how to measure the rate of motion? Distance traveled by an object, distance traveled by an object in unit time. So let us understand what we mean unit time. Okay, distance. How to measure the rate of motion? You can measure the rate of motion. Okay, this is one of the way. One of the way we can measure in other ways also. One of the way of measuring the rate of motion is distance traveled by an object in unit time. What do you mean by unit time? Unit in the sense it is one. Unit 1. Okay, then it may be 1 second. It may time, since it is time. What is the unit of time? Second, minute, hour. So it may be 1 second, 1 hour, 1 minute or 1 hour. Okay, so distance traveled by an object in 1 second. If you find out this, then that will be the speed of the object. So that will be the physical quantity which will measure the rate of motion. Okay, so that is called as the speed. Here they have given that this quantity is referred to as speed. Which quantity? Distance traveled by an object in a unit time is called as a speed. So what do you mean by speed? Distance traveled by this distance. Speed is defined as, okay, you can write as relative speed. It is defined as, it is defined as distance traveled by an object in unit time. Okay, so speed is defined as distance traveled by an object in unit time. Okay, so it is having the SI unit. Okay, so SI unit of speed is meter per second, or we can write like this also, ms to the power of minus 1. S to the power of minus 1. Why it is by since it is meter per second, that is meter divided by second, that means, okay, since power will be 1, right? Power will be 1, the thing is the power will be 1. If you bring s to the numerator, what will happen? If you bring s to the numerator, what will happen? S to the power of minus 1. You have learned in exponents lesson. Powers of exponents lesson. I am having y divided by x. If I want to bring, okay, not like this. If I am having x to the power of x to the power of 2. If I want to bring x to the numerator, what I will do? X to the power of 1. If I bring x to the power of numerator, x to the power of minus 2. I have learned in exponents, right? The same similar concept is applicable here also. So it is meter per second, it is meter per second or meter second to the power of minus 1. Okay, so like that. Okay, meter per second, or the SI unit will be either meter per second, or we can write like this. Okay, or otherwise, so this is one of the SI unit. Okay, this is one of the SI unit, or centimeter per second. We can call it as centimeter per second also, because distance will be measured in centimeter also, or centimeter second inverse, or otherwise kilometer per hour, or kilometer per hour. This is okay. So we can write like this also. So we are having 3 SI units. There is no hour, we can skip it hour, kilometer per hour. Okay, so what are the SI unit of speed? Centimeter per second, centimeter per, not centimeter per second, centimeter per minute, centimeter per what is centimeter per second? Centimeter per second. Centimeter per second. Okay, meter per second, centimeter per second, kilometer per hour. These are the 3 SI units of speed. So which is very, very important. How to define the speed? The speed can be defined as distance traveled by an object in a unit time. Distance traveled by an object in unit time. What is the SI unit of speed is meter per second, centimeter per second, or kilometer per hour. We are having 3 SI units. Okay. So to specify the speed of the object, okay, to specify the speed of the object, we need its magnitude. We need its magnitude. That means its magnitude is enough to specify the speed. Whether the object is moving very fast or it is moving at a very slow. to specify that its magnitude is enough. If I say that the vehicle is moving at vehicle A speed will be 50 km per hour, vehicle B speed is 100 km per hour, then you can say that by observing only 50 and 100 and its magnitude and the result as SI unit, you can say that object A will be moving faster than object B, right? So you don't want the direction here. You want only the magnitude. Only magnitude will specify that the object will be moving at the speed or the object will be moving at a faster or slower. The magnitude is enough. Magnitude is enough to specify the rate of motion. Correct? So therefore here we don't want the direction. We need only the what? Magnitude. So its magnitude will specify the rate of motion. So that is the next line. Object to specify we require only its magnitude. The speed of an object need not be a constant. The speed of the object need not be a constant in the sense like it is not same at each and every second. It may change. Like most of the cases will be a non-uniform motion only. In our day-to-day life, most of the objects will be moving at non-uniform motion only. So that means if it is moving at a non-uniform motion, its speed is not like speed is not like changing like 10 km per hour, 10 km per hour, 10 km. It is not going like 10 km per hour only. It may go at 10 km per hour in this time interval. It may change its speed at the next interval. It may again go slow down in the next interval. So it is changing because it is a non-uniform motion, right? So therefore, okay. So in such objects, so in this case, what we will call it as, since most of the motions are a non-uniform motion, in those cases we will call it as an average speed. Why do we have called it as average speed? Because it is a non-uniform motion. If it is a uniform motion, we can directly call it as a speed because speed is also uniform. Whereas most of the cases are a non-uniform motion, we will make it average speed. So how to find out the average speed? How to find out the average speed? The total distance covered from initial point to the final point. From initial, suppose you will be starting from Bangalore to Bangalore. Okay, you should find out the initial point and you should find out the final point. Initial point and then final point. What will be the distance traveled by you? You should measure that. What is the distance traveled? And in how many minutes or in how many hours you have completed? So that you should note down. That is total distance covered. Total distance covered. Then total time taken. You take total distance covered divided by total time taken. Divided